So today we are going to learn about the dimensional variables. So I hope in the last class we have learned about how to write a dimensional formulas for different physical quantities. I hope you have been thorough about it. So in mechanics and all we majorly use the three-dimensional values: length, mass and time. So the other fundamental quantities have been used in different fields. Okay, most probably all the physical quantities dimensions will be represented in terms of mass, length and time. So if I say the word dimensions, you have to remember immediately about what? The square bracket. So without the square bracket, we are writing any dimensional values means it is not in a right manner. Right? So now we are going to detailedly study about this dimensional analysis. Usually, the physical quantities has been divided into two things. One is a variable quantity, another one is a constant quantity. Variable means what? So, variable means with respect to time, the thing will be varying or it will be varying for different circumstances. We call that quantities as what? Variable quantities. If I say a constant quantity, what do you mean by constant quantity? Whatever be the circumstances and whatever be the situations, at all the time, the value of that physical quantity will remain the same. So, depending upon this variable and constant quantity, we are dividing the dimensions into dimensional variables and dimensionless variables, and at constants into dimensional constants and dimensionless constants. Right? So what I mean by that? So dimensional variable means the physical quantity will have a dimensions and that depends upon a variable one means we call that as a dimensional variable. So if I take an example, it is a length, velocity and acceleration. If I take length, so for different objects the length is varying, right? So if I am moving in a road, the length will be continuously varies with respect to time. So that is a variable quantity. Similarly velocity, acceleration, all are variable quantities and all these quantities have dimensions. We know that the dimensions of length is what? We can write it as simply L. Then what is the dimensions of velocity? We have found it, displacement by time taken. That's what I can say it is what? Lt power minus 1. That is the dimension for what? Velocity. Then what is the dimension for acceleration? It is Lt power minus 2. So because velocity by time taken, velocity is Lt power minus 1 divided by time, then it is said to be Lt power minus 2. So all these are variable quantities and these variable quantities possess dimensions. Then we call that type of physical quantities as dimensional variables. Right? Is it clear? Right. Then what is meant by dimensional variable? The physical quantities are variable one, but that physical quantity will not have a dimensions, will not have any dimensions. We call that type of physical quantities as dimensionless variables. If I take an example, specific gravity, strain and refractiveness. You are not able to remember what is meant by strain or refractiveness. You know refractiveness is vary for different material and it's gravity, not the specific gravity, and strain. Strain is nothing but what? Change in length divided by original length. So it will have no unit and that has no dimensions. So but these values vary for different objects. Right? The values will vary for different objects, but since it has been divided by same quantity with the same quantity, we will not have any unit, therefore we will not have any dimensions for these variables. So we call these types of physical quantities as dimensionless variables. Is it clear to you? So we are saying it as dimensional variable and dimensionless variable. The physical quantity which is variable, which has dimension means we call that as a dimensional constant. So dimensional variable, and the term physical quantity which is variable but doesn't have any dimensions means we call that as a dimensionless variable. Right? We are going to do the same thing for constants also. What is constants means? The value will remain same whatever be the situations, whatever be the conditions or whatever be anything, the value of the physical quantity will remain the same. We call that type of physical quantities as what? A constant quantity. Right? Now we are saying that what? Dimensional constant. What is dimensional constant? Physical quantity which is constant in value but has dimensions or possesses dimensions. We call that type of quantities as a dimensional constant. We say about gravitational constants and Planck's constant. We derive the gravitational constant. m power minus 1, right? M, L, T. So minus 1, minus 2 and 3. This is a dimensional value for what? Gravitational constant. Is it clear to you? So Planck constants also we can derive it. We can derive from de Broglie conditions, right? So lambda is equal to h by mv. So from that we can easily able to derive the Planck's constant dimensions too, right? So dimensional constants are constants which has a physical quantity which is constant but has dimensions, means we call that type of quantities as what? Dimensional constant. Then last is what? Dimensionless constant. What is dimensionless constant? The physical quantity will have a dimension which has constant but will not have any dimensions. We call that as a dimensionless constant. So we are dividing these dimensions into what? Four types from variables and constants. A variable has been divided into two. One is dimensional, another one is dimensionless. Next is constant has been divided into dimensions and dimensionless. If I say for dimensional constant, you know the value of pi. Pi is the standard value of what? We can say it is 22 by 7 or 3.14. So it is a value, it is a number. It doesn't have any what? It is a constant but that doesn't have any dimension. We are not able to represent the physical quantity in terms of a dimension. Therefore, we calling it as dimensionless constant. Is it clear to you? So we have studied about the basic introduction about dimensions and we studied about what are the four types it has been divided into. Now we are going to study about a very important concept which is called as principle of homogeneity, and we are going to study about the uses of dimensional analysis and its limitations, right? So now we are going to study about the principle of homogeneity. What do you know about homogeneity? Homo means what? It remains the same. So what is going to be remains the same? If I take any physical expression, the dimensions of each term in the physical expressions is going to remain the same. We call that condition as principle of homogeneity. Is it clear to you? So what is meant by homogeneity? So homo means remains the same. So the dimensional value in a given physical expressions, each term in a physical expression is going to remain the same. We are going to call that as a principle of homogeneity. So let us take one example. So here I have taken one example. What it is? V square is equal to u square plus 2as. So V is what? V represents velocity. U stands for initial velocity. V is a final velocity. U is the initial velocity. And A is the acceleration. And S is the displacement. So we know about the dimension for each value. So we will write the value. So velocity. Velocity dimension is what? Lt power minus 1. So the dimensions of velocity is what? Lt power minus 1. Since it has square, we are representing as square. Is it clear? Then that is equal to, what is the initial velocity? Same velocity, initial or final velocity, the dimension value is going to remain the same. Therefore, we are saying that Lt power minus 1, the whole square. Right, then plus 2. 2 is a number, it doesn't have any dimensional variables. So 2 is a number, it is a what? It is a dimensionless constant. So it has no value. So 2 is a constant one and it doesn't have any dimension. We call that as what? Dimensionless constant. And what is A? A stands for acceleration. What is acceleration? Is Lt power minus 2. Acceleration is what? Lt power minus 2. And second displacement is what? Again L. Now you check it. You multiply the square inside. It becomes to be what? L square T power minus 2. Again, this becomes L square T power minus 2. Then here again plus L into L. If it is the same term, the power will be what? Added over. So it becomes to be what? L square T power minus 2. If you check it, all the three terms in the expression, the value remains the same. We call this type of condition as a principle of homogeneity. We can take any number of expressions, right? So if I take a current expression, the dimension value on the left side and right side of the equation, or each term of an equation, the dimension value is going to be remains the same. We call that condition as a principle of homogeneity. And we are going to explain that, right? We can take any example. You can take your centripetal force F is equal to mv square by r. I will do and show to you in the second year. If we feel later, we will study about the dimensional verifications of a given physical quantity. So in that I will derive and show you, right? So any physical quantity we can take potential energy, mgh. So any expressions, what do you know, right? You can take the expressions and correct expressions, and if you are substituting the value, dimensional values of each terms and verifying all the terms involved in that expression will have a same dimensional constant, right? We call this as a principle of homogeneity. Now we are going for a very important concept which is called as uses of dimensional analysis. So we are going to explain. First we are going to study what are the uses, and then we are going to prove the uses one by one. So it is a very important part, and it is a very standard part, and it is frequently asked in your board examinations too, right? So what are the uses? So it will help me the dimension, why we are studying dimensions, right? So the dimensional knowledge will help me to convert a physical quantity from a one system to another system. What do you mean by one system to another system? So it can be help me to convert from CGS to, what is CGS? Centigram, centimeter or gram and second. So CGS to SI. Right? Or we can say SI to CGS or FPS to SI or SI to FPS. So we have studied about three systems, isn't it? So foot pound second system, centimeter gram second system, and MKS system, meter kilogram second system. So this dimensional analysis helped me to convert any physical quantity in a CGS form to SI form, or in SI form to CGS form, or so on. So the first uses is it helped me to convert a physical quantity from one system of unit to another system of unit. And the second one is it helped me to check the dimensional correctness of a given equation. It is a similar one what we have done here, right? So what we have done, we have checked the dimensional values. So whether all the terms have the same dimensional value, then I can say this equation has the same. So this equation is a very correct equations. If the dimensions of each term is not in a perfect order, means then the equations what we have written is wrong. Is it clear? So we are saying that as a check the dimensional correctness of a given physical quantity. Right? So if I write any equations, we have to check the dimensional values. If the dimension values of the left side and right side of the equations remain the same, then we can call that equations as a dimensionally correct equation. Then now what is the last one? Establish the relations among the various physical quantities. So we can say, if I take a simple example of simple pendulum. So if a simple pendulum means what? I need a long thread, I need a bob, and I need a stand and so, right? But the simple pendulum experiments to calculate a time period depends upon length, mass, gravity and so on. But I don't know about how far it has been related. Is it directly related or indirectly related? Is it a square-able one or a square-root one? So we don't know. So we can depends upon the given values, and we can easily able to relate the one physical quantity with the another physical quantity. So we call that as the help of what? Dimensional analysis. We call that as the uses of dimensional analysis. So it is a very standard important 2 mark questions, and the explanation for this one is a standard 5 marks one, and we are going to see one by one, right? Now again we recall about what is the uses of dimensional analysis. What is the uses of dimensional analysis? The first one, it helped me to convert a physical quantity from one system of unit to another system. And second one is what? It helped me to check the dimensional correctness of a given equation. And the third one is what? It helped me to establish the relations among the physical quantities among the given terms, right? So these are the 3 terms. So what we have seen? So we have seen about the principle of homogeneity. What is the principle of homogeneity means? If an equation is given means each term in a given equation will have the same dimensional values, then we call that condition as what? Principle of homogeneity. Then we studied about what? The 3 uses. Conversion of one form to another form. Check the correctness, dimensional correctness of a given equations. And the third one, to establish the relations among the various physical quantities in that expression. Right? Now, we will do an examples for convert a physical quantity from one system of unit to another system. So we will do a 2 sums. So one is we will take pressure in terms of CGS, and we will convert in terms of SI, and we will take a gravitational constant, we will convert it SI into CGS. right? So for that we will take a first example. So what it does, so they have given 76 centimeter of mercury pressure into Newton meter per minus 2. So what they are asking, 76 centimeter of mercury pressure, that is given, the value has been given in CGS system and they are asking us to convert into SI system in Newton meter per minus 2 using your dimensional analysis. So they have given not the pressure, so they have given 76 centimeter, means they have given the height. So from that value we have to calculate the pressure in terms of CGS. So we know the formula. In lower admin 8th standard or 9th standard we have studied about the pressure. So pressure can be given by the formula H rho G. So H stands for the height of a liquid column and rho stands for the density of a liquid and G stands for the gravity. And it has been given in terms of what? Centimeters. So we are taking the term in terms of CGS. So what is the height? So we can say that it is 76 in terms of centimeter. And density is, we have to know that the specific density of a mercury is 13.6. So the specific gravity of a mercury is given by what? 13.6. And G is what? Gravitation value is what? 9.8 meter per second. But here centimeter has been given. So we are going to write that meter in terms of centimeter. So 9.8 into 10 power minus 2 means we can write it as it is 980. So this is the pressure. Pressure is equal to what? Force by area. So force by area means what? The force in terms of CGS is done. Area means what? Centimeter minus 2. Is it clear to you? So pressure is given by the formula what? Force by, pressure means what? Force by given area. Force by area. So in order to calculate the pressure from the 76 centimeter of mercury, we are using the term H rho G. H stands for the height of a liquid column, rho stands for a density, that is specific gravity, or G stands for a gravitational G value. And G value is 9.8 is in terms of meter per second. Now I need it in centimeter, therefore we are writing this what? 980. So force unit in CGS is what? Dyne. So we say that the force unit is Newton in terms of SI. In terms of CGS we call that force unit as what? Dyne. Dyne centimeter per minus 2. Now we are going to convert this CGS value into SI. So we are going to form that a numerical value into unit. We are going to do this the fact of what? The numerical value is along with what? The unit term. So we will write a term like this. What we can write? So P1. Or we can write the P instead of P1 I can write in order to clearly understand P CGS. That is pressure in terms of CGS, which depends upon M, L, T. So we don't know how far it has been created. I can say that M power A, L power B, T power C. And that is equal to pressure in terms of what? SI. With the same dimension value, M. We can say here M1, L1, T1. In order to differentiate M2, L2, T2. Right? So here we get A, B and C. So for that we have to calculate the dimensional value for force. So what is the dimensional value for pressure? Pressure is equal to force by area. Force is equal to what? Mass into acceleration divided by area. So mass dimension is capital M and acceleration is what? L3 power minus 2. And area is what? L square. This gets cancelled. Therefore what? It becomes to be M, L inverse, T power minus 2. So that is a value for what? Dimensional value for pressure. Listen, pressure is equal to force by area. Force in terms of what? Mass into acceleration. Mass dimension is M. Acceleration dimension is L3 power minus 2. Area is what? L square. L square. It cancels. Therefore it becomes to be what? M, L inverse, T power minus 2 is a dimensional value for what? Pressure. So we can say that the same value, right? So from that M, L, T power minus 2. Right. Then what we are going to calculate? We know about CGS. We want to calculate in terms of SI. So for that we have to know the values of these terms. So we'll take this. So let it take M1, L1, T1. So M1 can be set to everything is a 1. So 1. Mass in terms of what? Gram. Length in terms of what? Centimeter. Time in terms of what? Second. Then we are going to substitute M2, L2, T2. So in SI M2 will be given in terms of what? 1 kilogram. L2 will be given in terms of what? 1 liter. And T2 will be given in terms of what? 1 second. And this A, B and C, we are going to compare this with this equation, and from that we can say that A is equal to, what is A value? So A, B and C, this is A, this is 1. A value is 1, B value is minus 1 and C value is minus 2. Is it clear to you? Right? What we have taken? First from the sum 700 centimeter of mercury, we have calculated pressure value. So pressure value is how we have calculated? We are calculating using H, rho, G. So H is a height, rho is a density and G value is 980 in terms of what? Centimeter. Then we have taken the method of what? Numerical value into its unit. So we have taken CGS terms into its dimensional one. SI into dimensional, we are saying that these two terms are what? Equal. So from that we are defining the values of M, L and T. In CGS system it will be given in grams, centimeter and second. In SI system it will be given in meter, kilogram and second. Then the value of A, B, C has been calculated from what? The original dimension value of pressure. So from that we have calculated it. Now we'll do it. So what we are going to calculate? We are going to calculate it for P into SI. So what we are going to do? So I will write it here. P into SI will be equal to, I will make it to other side, into PCGS, that is equal to M1 divided by M2 the whole power A. Then L1 divided by L2 the whole power B. Then T1 divided by T2 the whole power C. So we have taken the term to other side and we have divided the same term with the same equation. Now we are going to substitute the value of M1, M2, L1, L2, M. So what is the value? So P of SI will be equal to P of CGS into, what is M1 values? M1 value is 1 gram. 1 gram divided by 1 kilogram. The whole power A. What is the A value? A value is 1. So what is A value? A value is 1. Then L1. L1 is what? 1 centimeter divided by 1 meter. The whole power. What is B value? So B value is what? Minus 1. B value is minus 1. Then 1 second divided by 1 second. The whole power. What is the C value? C value is minus 2. Is it clear? So we have taken the term of M2, L2, T2 to the other side and we have substituted the value of M1, M2, L1, L2, T1, T2. M1, L1 and T1 are in series form. M2, L2, T2 are in terms of what? SI form. So series means what? 1 gram, 1 kilogram, 1 centimeter, 1 meter, 1 second, 1 second. Where the value A, B, C came from? A, B, C came from a dimensional value of pressure. So from the dimensional value we have taken A, B and C. Is it clear to you? Now we are going to cancel. So here second and second will cancel, but centimeter and meter will not be cancelled. Gram and kilogram will not be cancelled. So we have to convert that into a same term. So in order to convert that into a same term, we know that. So what is the term? We can say that PCGS is equal to, so what? 10 power minus 3 kilogram. 1 gram is equal to what? 10 power minus 3 kilogram into 1 kilogram. The whole power 1. Then 1 centimeter in terms of meter is what? 10 power minus 2 meter divided by 1 meter. The whole power minus 1. So this has been cancelled. So it is 1. So it is 1 the whole power minus 2. So 1 to the whole power minus 2, the value will remains to be what? 1 itself. Now this kilogram, kilogram cancelled, meter, meter has been cancelled. This power has been multiplied with the unit power. Right? Then what we can say? We can say that is equal to what? PCGS is equal to 10 power minus 3 into 1. 10 power minus 3. Then into 10 power minus 2 into minus 1, it becomes to be 10 power plus 2. Right? Then what it will be? What is pressure in CGS? What you have calculated? We have calculated equals 76 into 13.6 into 980. That is this pressure in terms of what? CGS into this term 10 power minus 3 plus 2, it becomes to be what? 10 power minus 1. Right? So we are going to multiply it. If I multiply it, we get the value is equal to 1 point. We get the value is equal to, we can say that it is 1.01. 1.01 into 10 power 5 Newton meter per minus 2. If we multiply, we can get it. So this value is pressure in terms of SI. So what is that? This is the pressure in terms of SI. Is it clear to you? So So what we have taken, we have divided the term N2 L2 T2 and we have substituted the values in respect to CGS and SI, and we have converted the gram in terms of kilogram and centimeter in terms of meter, and we have cancelled the unit and we have multiplied the product. So we have multiplied and therefore the term has been given in terms of what? SI. So we can easily able to convert it from what? SI, that is what? CGS, the CGS value to a SI value. Right? So this is where the dimension has been very useful in converting one physical quantity from one system to another system. So again I will recall it, listen to it. Right? So what we have been taken, they have given 76 centimeter of mercury pressure. So 76 centimeter means what? So they have given about the height of a liquid column. So it is not a pressure. So in order to calculate the pressure value, we have taken the formula of what? H rho G. So H rho G is what? H stands for height and rho stands for a density and G is a gravity. Gravity value is what? 9.8 meter per second. But it is a CGS form. We want to write in terms of centimeter. So we have written as 980 centimeter. Right? Then for pressure, what is the formula unit of pressure? It is a force by area means what? Newton per meter. In terms of CGS means the Newton value is given in terms of what? Dyne per centimeter square. Is it clear? Then what we have taken? We have taken pressure in terms of CGS into M1, L1, T1. Right? A, B, C. So we don't know what power it has been depends upon. We don't. Then that is equal to what? Pressure in terms of SI into its dimensional values. Then what we have done, so we itself taken the value of what? M1, L1 and M1. We have to include everything in what? Square bracket. So if a square bracket is not that means it is not a dimensional one. Right? We have to take everything in terms of what? Square bracket. So we have taken the square values in terms of mass value, in terms of CGS, it will be represented 1 gram. Length will be given in terms of 1 centimeter. Time will be given in terms of what? 1 second. Mass here in SI, mass will be given in terms of 1 kilogram, length will be given in terms of 1 meter and time will be given in terms of 1 second. This one we are writing as per our knowledge. Then we are taking the value of this A, B and C from the original dimensional value of a pressure. So we are calculating the value of pressure. Pressure is equal to force by area. So from that value we have calculated the dimension of pressure to be what? M, L power minus 1 and T square. So this is A and this one is B and this is C. So A is equal to 1, B is equal to minus 1, C is equal to minus 2. So we have calculated all the values. So we want to calculate pressure in SI. So we keep this to one side and we take this M2, L2 to the other side. So which has the same power and same term will be divided. So we say that M1 by M2, L1 by L2, T1 by T2. So look at here. Yes, so we have taken PSI is equal to what? PCGS. So M1 by M2 the whole power A, L1 by L2 the whole power B, T1 by T2 the whole power C. So we have know all the terms, right? M1 we know, M2. So we are substituting all the terms and we want to cancel it. So if we cancel it, it is of different unit. So we are making into the same unit. So 1 gram is equal to what? 10 power minus 3 kilogram. 1 centimeter equal to what? 10 power minus 2 meter. So we are cancelling each other and we are substituting the value of A, B, C and we are multiplying it. And we already calculated the value of what? CGS is 76 into 13.6 into 980. And we are having the 10 to the power here. If I multiply and divide, so we have the value equal to what? 1.01 into 10 power 5, which is in terms of SI we have converted. So we say that because everything in terms of what? Kilogram and meter we have converted. So we say the unit to be equal to Newton meter per minus 2. So hence we can easily able to convert the physical quantity of pressure in terms of CGS to SI. Right? Again we are going to see one other example with respect to what? Gravitational constant. So let us do it. So now we are going to convert the same method. First we have converted the pressure in terms of CGS in terms of what is SI. Now we are going to do the reverse. So they have given what? So gravitational constant in terms of SI, that is equal to 6.6 into 10 power 11 Newton meter square kilogram minus 2. Right? So Newton meter kilogram means what? The value has been given in terms of what? SI. So it has been given in terms of SI unit. So we want to convert that into CGS. Right? convert from one system of unit to another system of unit, right? So we'll do what we have first. What we have to do first, we have to write the equal parameter, right? So equal parameter on g of si into m1 power a, l1 power b, t1 power c. That is equal to gravitation of what? CGS. CGS in terms of what? M2 power A, L2 power B, T2 power C. So we have written it. So we are going to make use of this method, right? So we are going to use the value with this dimension as a product, n into u, right? N u, right? So then what we have to do? So we have to define the values of each term. So this is what SI. SI is what? M1 is square bracket. SI is what? In kilogram. Then L1 in terms of what? It will be given into 1 meter. Then T1 will be given in terms of what? It is 1 second. Right? Similarly, in terms of CGS, so M2 will be given in terms of what? M2 will be given in terms of, yes, what it will be? 1 gram. L2 will be given in terms of, yes, 1 centimeter. Then T2 will be given in terms of what? 1 second. So we have defined M1, L1, T1, M2, L2 and T2. Now what we have to define? We have to define about A, B, C. So where we have to get the value of A, B, C? Yes, it is from the gravitational values. That is for dimensional value of a gravitational constant. So we have already calculated it. We know that F is proportional to product of mass, is directly proportional to product of masses and square of a distance. Then F is equal to what? G into M1, M2 divided by R square. So you want to calculate this dimension. So G is equal to F into R square divided by M square. What is M value? What is force value? Force value is what? Mass into acceleration. Mass into acceleration. Then R square is distance, L square. Then mass, M square. Then what it becomes to be? This and gets cancelled. Right? Then what it will becomes to be? Force into, here we can say L square and L cube. So we can say that M power minus 1, L square and 1 whole power 1 becomes to be L cube and T power minus 2. So that is the dimensional value for what? Gravitational constant. And from that we can say that A is equal to minus 1, B is equal to what? 3 and C is equal to what? Minus 2. So is it clear how we are calculating? You can simply remember it. You can write like this. So you can write M, L, T. There is no need to divide this, right? If you know this dimension value, you can directly write. So you can have a remember like this. We can take M, L, T and we want to substitute 1, 2 and 3. No. So we have write 1 here, 2 here, 3 here. So we have to put alternately, we have to put minus. Right? This is roughly to remember it. Right? We have substituted M, L and T. Then we are writing 1, 2 and 3 here and we have to put minus sign for the first and the last one. So we will get this dimension. But really we have to work it like that. So there is no need to explain this in the problem. If we know the dimensional value of a gravitational constant, directly we can write it. So in order to not make the mistakes, we have to remember that M, L, T, 1, 2 and 3 and put minus sign for the first and the last term. Is it clear to you? So we have found the value of A, B, C and we have found the value of M1, M2, L1, L2, T1, T2. What we have to find? We have to find the G of CGS. So what we have to do? We have to bring this to the side. Then what will happen? So we have till now we have said that. So this SI value of gravitational constant has been given by the value 6.6 into 10 power minus 11 Newton meter square kilogram minus 2. And we have equated the SI value and the CGS value. And we have written all the values in terms of SI and we have written everything in terms of what? CGS. Then using the dimensional formula for gravitational constants, we have arrived at the value for what? A, B and C. Now we are going for the step to calculate what? C of gravitational constant in terms of what? CGS. Therefore, gravitational constant in CGS will be equal to gravitational constant in SI. So into, we are going to divide each term, later terms with the so M1 by M2 the whole power A. Then L1 by L2 the whole power B. Then T1 by T2 the whole power C. right? Now we are going to substitute the value of m1, m2, l1, l2, t1 and t. Right? We write that is equal to g of si into what is 1, m1, l1, t1 in terms of what? Si. m2, l2, t2 or in terms of what? Cgs. Therefore, 1 kilogram divided by 1 gram, the whole power a. What is a value? A value is -1. Then, L value 1 meter divided by 1 centimeter, the whole power. What is our B value? Whole power 3. Then 1 second divided by 1 second, the whole power -2. Is it clear? Now we are going to cancel it. What are we going to cancel? Second gets cancelled. Same unit gets cancelled. So 1 to the power of anything, the value, the entire value becomes to be what? 1. Right? Now we are going to cancel this term. So we have to make it as a same unit, either in terms of kilogram or in terms of gram. If I want to convert into gram to kilogram, I can write 10 power -3 kilogram. Here 10 power -2 meter. Or I can do it what? I can convert kilogram into gram. Kilogram is what? I can say G of SI will be equal to 1000 gram, right? 1000 gram divided by 1 gram. Whole power -5. Then 100 centimeter, right? 100 centimeter will be 1 meter. 1 centimeter. The whole power 3. So this value will become to be what? 1. Then this gram and gram get cancelled. Centimeter will get cancelled. Then we have to multiply the power with the 1. So G of SI will be equal to 3 into -1, 10 power -3. Then 3 into 2, it becomes to be what? 10 power 6. So therefore I can say that G of SI into 10 power +3. Then what is G of SI which has given in the sum? So it has been given at what? 6.6 into 10 power -11. So that will be equal to, we can say that 6.6 into 10 power -11 into 10 power +3. Then it becomes to be what? 6.6 into 10 power. By those 3, it becomes to be -8. Now we have converted what? In SI form into series. So we have to write this unit in terms of series. N stands for what? Newton. Newton in SI will be written in series as what? Dyne. Then next is what? Meter square. Meter square will be written in terms of what? Centimeter. Centimeter square. Then next, kilogram power -2 will be written in terms of what? Gram power -2. So this is the value of gravitational constant in what? CGS system. So we have converted. What we have converted? We have converted the gravitational constant which has been given in terms of SI into what? CGS. Is it clear? So again I will repeat it. Listen to me. So gravitational constant of SI has been given the value of what? 6.6 into 10 power -11. Right? Note it out. It is -11. Right? Newton meter square kilogram -2. Then what we have taken? We have taken the nu value, right? So gravitational constant into dimensional value, that is equal to gravitational constant into dimensional value. Then we have written the dimensional values in terms of SI value we have written, and in terms of CGS we have written. Then in order to find the value of A, B, C, we have calculated the dimensional formula for what? Gravitational constant. So from the dimensional value we have written the value of A, B and C. Then to what factor we have to find? We have to find CGS. So keeping that in one term, and we are bringing all other to the next exercise, and we are dividing the same parameters and substituting the values of the known values and cancelling it. By cancelling it to converting into a similar unit, we will get reduced. The value will get reduced to this, and we got this value in terms of what? CGS. So using a dimensional analysis, we have converted the gravitational constants in terms of SI into CGS. So it is a very simple one. So if you do and practice it, it becomes very easier, and it is a very standard question for your board examination, right? Surely they will be asking these types of questions, and also it will give you a nice knowledge to work on a competitive based problems too. So like this problem we will ask. So after finishing our lesson, we will go for the competitive based analysis. So that you find it very difficult, and we will put a shortcut methods to derive this, right? So practice this one. It is a very important one. So one method you have to know that first we have to take the value, then we have to equate it and we have to write the value by our own. If it is in SI, we have to write it in kilogram, meter and second. If it is in CGS, we have to write it as gram, centimeter and second. Then we have to find the value of what? ABC. So ABC value is from the dimensional values. Then we have to substitute it and we have to make it as a similar term. Remember that you can convert anything. Kilogram in terms of gram also you can convert it, or gram in terms of kilogram also you can convert it. Only thing, these two units should be the same and we have to cancel. If I convert this into that, it will becomes to be 10 power minus 3. Then 10 power minus 3, if I bring it from opposite, it becomes to be 10 power 3. The same one. You can convert by any method, right? So only the thing is the two units should be the same, therefore we can cancel the units. Right? So we have to do it and we have to substitute it and we have to find the value. So it can, this dimension analysis is a very easy and simplest method and is a one-name method which helps me to convert any physical quantity from one system of unit to another system of unit. Right? So practice, do and practice this. Right? Thank you.